Hello, everyone. We'll get started in just a few minutes. Okay, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are going to cover SPSS data cleaning and management steps. If you haven't joined us before, I usually go through the entire presentation first, and then I'll do a Q&A session at the end. If you do have questions, my colleague Sierra will be assisting me today. And she'll be providing hyperlinks about the services, and she'll be providing self-schedule links if you have any questions about the services we provide. We will be sending everyone a copy of the recording of the webinar, as well as a copy of the PowerPoint following the presentation. All right, let's go ahead and dive in. So first, I'll give a brief overview of the services we provide at our company. Then we will discuss SPSS data cleaning and management. I will be going through a sample spreadsheet. Then we'll conclude with a summary and a Q&A session if you have any questions. So our company, Statistics Solutions, assists with every part of the dissertation journey. We have quantitative and qualitative specialists, as well as literature review specialists. So we will assign a specialist to you depending on where you need the most assistance. As you can see in the bullet point list here, we help with almost every part of the dissertation, going from topic development all the way to final defense preparation. So we can help you frame your research questions, determine what are the best analyses to address those questions, what is the best research design that applies to the study, maybe quantitative or correlational or experimental, and we can help you justify those decisions. As far as the literature review, we can help you identify a theoretical framework and find articles to support your topic and identify a gap in the literature. And then we help with IRB forms, data entry templates. We can host a survey for you on SurveyMonkey, and we have both quantitative and qualitative results assistance. So if you have any questions about the services we provide, you can schedule a free consultation at 727-442-4290. On this slide, I have a couple hyperlinks that will present the previous webinars that we've done. That will be in the archive link, this bottom one. And you can view the recordings that we've done for previous presentations, and then you can also register for future appointments. So assuming you've collected your data, you're following a quantitative study, and you've decided to use SPSS, which is probably the most popular software used today for data analysis. You can use SPSS to crunch your numbers, to clean the data, to make sure it is ready to analyze. And if you use a platform like SurveyMonkey or Qualtrics, you can extract the data directly from SurveyMonkey and Qualtrics into SPSS, which is a cool little procedure, as it really saves the time of entering data in manually It's already organized perfect format for you from those websites. The first thing you want to do is add an ID variable so you can quickly identify all the participants in your data. Usually when you do data analysis, you want to make sure everybody's de-identified so you don't have characteristics like name or email address or phone number. You want everybody to be anonymous and confidential. So first you want to add some identifier, and you can just use a number for that. Then you want to name every variable of interest in your spreadsheet. So maybe you have demographics at the beginning, gender, race, ethnicity, age. You can name the variables with a short phrase. And if you're using a survey like the job satisfaction survey, you'll want to name every survey item and just use a sequential number to indicate what number item it is. Job satisfaction 1, 2, and 3, and so forth. And probably the best advice I can give is saving your spreadsheet often. So anytime you do a drastic or any step that is changing the spreadsheet drastically, I would say, like reducing the sample size or recoding a variable or replacing missing data, you want to save the spreadsheet after every one of those steps, just so in case you can go back to a particular step. If your committee asks, you can pinpoint, hey, I made this adjustment. I removed 10 cases in my spreadsheet at this step. You can highlight when that happened. I do have a sample spreadsheet here of some data that was collected that measured 3 variables of interest. It first measured leadership effectiveness in the workplace, these 7 items. Then it measures job satisfaction with these 6 items, and then organizational performance with these items. The data here was downloaded directly from SurveyMonkey, so this is exactly how it looks when I first received it. And the first thing you want to do is kind of look in data view and eyeball for any missing data or any anomalies, things you don't expect. And right off the bat, I can see there's somebody who provided consent, but then did not respond to anything. So mental note, you probably need to take this individual out. I also see some cases that are missing just an item here and there. And there are many ways to handle this, which we'll talk about. But this is a case, if someone misses one response, you don't really want to remove their entire data. You want to try and keep the sample size as large as possible. So yeah, first off, I see some missing responses for people who didn't complete the entire survey, and then just some missing responses in the middle. Okay, the first thing we need to do is create an ID column. So I usually create it as the first variable. You right-click the variable name and then insert a variable. This will be our ID, okay? And I can see we have 91 people who consented. So you can go into Excel, start a list. For some reason, unbeknownst to me, you can't do this in SPSS, to my knowledge. But if you just start a list and then drag down to 91, there you have it. You can just copy and paste. And now I need to give this variable a name. So I need to go into variable view. You can either click variable view or you can double click the variable name here, and it'll take you to variable view. I'm going to call this ID. The next thing I need to do is label all the variables of interest. So we had a demographic question at the beginning for years of service. So I'll just call it years of service. Then we need to name these variables for job satisfaction and effectiveness. So again, you can do this in Excel. First 7 items. We're measuring leadership effectiveness. So just start the list with 1 or 2 cases, and then you can drag down. Next portion was job satisfaction. And the final portion, organizational performance. Okay, so now we can copy and paste this from Excel into SPSS. We have named our variables of interest. Important to note that you can't have spaces in between the variable names. You need to have it all as one concise phrase. Try to make it just a few words if possible. So these are all labeled. And another important thing to note is what is the variable type? Okay, so generally anything that is numeric, you'll want to see numbers for those variables, and things that are string usually means it's categorical. What I know about the survey is that all of these questions follow the Likert scale from 1 to 5, meaning strongly agree to strongly disagree. So some of the data was collected numerically, but the organizational performance part was collected as words, fill in the blanks essentially, or multiple choice with words. So eventually we'll need to change these to numbers, and we will discuss that. Okay, so after this, we made a couple adjustments. I'm going to save the spreadsheet. And usually when I save, I'll put today's date and then the sample size as well. Full sample. Okay, that's step 1. The next step, which we just talked about, is recoding Likert scale items from string format, which are words, into numeric format. Okay, so let's tackle that step. We need to change these 5 responses to numbers. So we will go into data, or I'm sorry, we'll go into transform and then recode into same variables. I'm going to move over these 5 organizational performance items to the right box. And now I need to identify what the old values are and what I'm changing it to be a number. So the way you can do this is you can copy and paste. And I actually recommend copying and pasting because there may be spaces after some of these or spaces before, but it's very important that you have the exact phrase in here when you change it to a number. Otherwise, it might change some to numbers, and others might stay as words. So I'm going to copy strongly disagree right here, go into old and new values. The old value is what it originally is, words, and we're changing the new value to a 1. Strongly disagree was a 1 and strongly agree was a 5. Click continue, and then we do the next one. Disagree is a 2. Neither agree nor disagree will be a 3. Agree will be a 4. And finally, strongly agree will be a 5. Okay. 2 options here. To run any code in SPSS, you can either click OK, and it's going to run that command, or you can click paste, and paste is going to generate syntax. This is what syntax looks like after I click paste. This is what it provides. So this is essentially the code for running a change in a variable from string to numeric, recoding essentially. So if I want to run this code, I just need to highlight and click this green arrow, and you'll see all of these words change to numbers. Okay, so highlight, click the green arrow, and just like that, these are all numeric now. Now you'll note that the numbers, the variables with numbers, have these little rulers on them because it sees that it's numeric and it's scale. for organizational performance, it still thinks that these are string variables, meaning words. So we need to manually change these to numeric in variable view. So I'm in variable view here. And if you just copy numeric in a previous cell and drag down, let me do numeric, copy. Okay, so now it knows that these are all numeric. Very good. The next step is identifying reverse coding. So this is a procedure that is used if you have negatively phrased items. It's a very common procedure. If you just Google or YouTube some videos on reverse coding, they explain it pretty well. But the basic idea is that you may have negatively phrased items as part of a scale. And we do have an example of that here. Job satisfaction, the way this questionnaire was gathered is that a 1 was strongly disagree and a 5 was strongly agree. Okay, so higher scores should be representative of higher job satisfaction. Now, if we have a positively phrased item like this one here, my job responsibilities are clear, we would hope that a higher response to this means higher job satisfaction. But there are a couple negatively phrased items like this one here and this one here. I am not provided with the tools and equipment I need to do my job. So that is a negatively phrased item that we want a 1 to be strongly agree and a 5 to be strongly disagree. If they disagree with the statement, that means that they have higher job satisfaction. Likewise, with this item, we would hope that a 5 is strongly disagree, so that if they disagree, the participants have higher job satisfaction. Okay, so we have job satisfaction 2 and job satisfaction 4. We're going to use a very similar procedure as we just used to change from string to numeric. What we'll do is go to transform, and instead of same variables, I'm going to do recode into different variables. And what this does is it creates a copy of the same variable. So we're going to keep our original 2 items in here intact, but then we're going to create a copy of them that are reverse scored. So we need to move over job satisfaction 2 and 4 to the right box. We need to give it a name. Job satisfaction 2 reverse. And job satisfaction 4 reverse. Reverse coding is just flipping the Likert scale. Okay, so once I click old and new values, I'll put a 1 in this box, and this becomes a 5. We're inverting the Likert scale. 2 becomes a 4, 3 stays the same, 4 becomes a 2, 5 becomes a 1. So as you can see, we go up 1, 2, 3, 4, 5, and down 5, 4, 3, 2, 1. And again, instead of clicking OK, I like to click paste, and we can generate syntax. This is really useful for keeping a running record of all the analyses you're doing. Kind of tells a story of all the steps you took. Then you can also put notes in here if you use the asterisk like this. And this first one was changing from string to numeric. So if you start with the asterisk, it becomes a comment, and you end it with a period. And this is changing reverse coding. Like this. Okay, so again, I'm going to highlight this code and click the green arrow. Now we have job satisfaction 2 and 4 reversed. What we need to do is put these 2 items in the correct order. Okay, so I'm going to highlight these 2 and then click and drag. We want it to be in the correct order of the survey. So job satisfaction 2, the original one, I'm just bringing to the bottom. don't need these two anymore. We need the reverse coded ones. And we can take the value that this column shows you what the survey question is asking specifically. So I do need to copy this and put it here, and copy this and put it here. Now we have job satisfaction 1, 2, 3, 4, 5, 6, perfect order. And that tackles this step. So again, I'll save, and it's important, be as descriptive as you can. Here we change from string to numeric and reverse coded. All right. The next step is reviewing missing data. Okay, so there are many ways to handle missing data. It really depends on the reference you read, because there are so many different ways to handle it. But something to note is that if you're far above your sample size requirement, then you can consider removing any missing responses. You know, if you're targeting 100 people and you have a sample of 1,000 people, ideally you want a sample of just complete responses. So you have room to lose people in that case. Just a side note, to do a minimum sample size calculation, you need to do a power analysis, which this is G-power. And for instance, if you're doing a t-test, you know, comparing, say, job satisfaction between males and females, you do a t-test and G-power will tell you the minimum sample size. So we need 128 people, ideally, to run this t-test, which would be 64 males, 64 females. So there's a power analysis for almost every key inferential analysis, like correlation or regression. Linear regressions are based on the number of predictors you have. So say we have a regression with one predictor, you only need 55 people. But as you increase the number of predictors, you need more participants. Okay. Kind of a prerequisite, you know, if you have a large sample size, then I think you have the ability to remove people more freely. But if you're really scrounging to keep people in the study, then you have to find an alternative. So there are more complex procedures like imputation. Imputation will predict missing responses. And this is actually something that is provided in SPSS here. If you go to analyze, I'm not sure if it's the basic version, it might be a more complex version of SPSS, but you can impute missing values. It's essentially predicting what the missing data should be, dependent on how people responded to the survey. But that is more complex, and there's a lot of literature that goes into it. The more straightforward procedure is replacing the missing data with averages or medians. And I'll show you how to do that. So before we do that, actually, we need to eliminate the people who didn't respond at all. Okay, so there are maybe 5 or 6 of them. A quick way to find those cases is pick any column in the spreadsheet, right-click that column, and sort it in ascending order like this. Now you can see all the missing responses have been pulled to the top. Looks like we have 5 of them. Let me just scroll down to make sure we're not missing any. So we can delete these 5 rows because they just provided the demographic response for years of service, and then they dropped out. Don't have any useful data for these people. So just highlight these rows, right click, and then clear. Let's go ahead and save again. So it's no longer a sample size of 91. Now we have 86. You remove 5 cases. Remove non-responses. Okay, and as far as replacing the missing data, so we want to replace this missing value with the average or the median of this column. You'll see arguments for both sides. Given that these are primarily Likert scale data, I'll use medians in this example. So what you do is you go to transform, or you go to data. Let's see, where is it? Transform, it's under transform. So transform, replace missing values right here. And then what we're going to do is just put every item in here. Okay, just to illustrate this, I'll use the mean because it's more efficient right now. We have so many items, but you can see here, this is where you change your method. You can take the average of the missing columns, which is what we're doing right now, or you can take the median of nearby points. Both methods are applicable. It really depends on source that you're reading. Okay, so then we'll go ahead and click paste. And clicking paste for this is going to give you this code. And once I highlight and run this code, you'll see it's now created duplicates of every variable of interest. Okay, and when I look at these, there should be no missing values at all. Okay, let's find an example of one that was missing before. This one right here, so job satisfaction 3, towards the bottom, job satisfaction 3, this is that value. You can see it's been replaced with the average. Now you can use the median as well. And I've even seen the mode used. The mode is the most common response given, and that can be used for replace as well. Okay, so now we really just need to use these bottom variables here. We don't need to use anything above it, but I like to keep it in the spreadsheet just for consistency. I think it's good to have the original variables intact, just in case if you need to go back to it at some point. So I'm copying all of this and pasting it right here. Okay, so that's missing data. Let's go ahead and save again. Paste missing data, average. The next step is creating composite scores. Now, when you're using a Likert scale survey, like the job satisfaction survey or the MLQ for leadership or the burnout inventory, usually you're not looking at every item on its own. When you do inferential analyses, you need to create an overall variable that summarizes organizational performance. And we need an overall variable that summarizes job satisfaction. And usually that's done through an average or a sum of the Likert scale questions. You'll have to look at the scoring instructions for the survey specifically, which is a whole side note that you should probably use a survey that's been validated before. You don't want to create your own, as it involves pilot testing and you have to prove that it's reliable and valid. So it will save you time to use a previously validated surveys, and during those validation steps, scoring instructions are developed. And usually you take an average or a sum. So to do this, we'll go to transform and compute variable. Need to give the overall variable a name, leadership effectiveness. Overall. And then we're going to take an average of all the items, leadership effectiveness. You can do this 2 ways. You can input every item and then click comma and put the second one, comma, third one like this. Or you can just put the first item, write the word to, and then put the last item like this. As long as the items are in the same order, thus, so it's going from 1 to 7. And then I'll click paste. Let's do the same thing for job satisfaction. making sure that we're using the reverse coded items, right? And I just noticed I'm not using the right one, okay? You have to be really careful that, remember, I kept the original items intact here. I need to be using these ones down here. That could be a little confusing. It might be best to just remove these if you don't want to get confused about what variables what. I like to keep them in just for reference. But what we'll do, we'll put leadership effectiveness. And I didn't put the right items. It needs to be these ones down here. Notice that it has an _1 after it. The ones with the _1 are the ones that have replaced the missing values with the average. Job satisfaction is next. And making sure, very important, that the reverse coded items are being included. And finally, organizational performance. All right, I clicked paste every time. I have the code for these now right here. So this is creating composite scores. If I highlight these three and click the green arrow, it's going to create those three variables right here. Now we have an overall score for all three variables of interest. Okay. The next step is identifying outliers. Also, there are many ways to do this. You can do it visually, with box plots or scatter plots, and you can also do it mathematically with standardization. Okay, so creating standard deviations and scores. I'll show you both ways. So the first way is with box plots. You can go to Analyze and Descriptives, and then Explore, and then put in your three variables of interest in this right box. And I think that's it. There is an outliers box there. That's really not what we need. We just want box plots. It should be generated from this. And so I just ran that. And this is what we're looking for. There will be one box plot for each variable of interest. We can see leadership effectiveness here. An outlier will be identified with the star. If there are any extreme low or high values, you'll see a star for those values. So for leadership effectiveness, we don't have any outliers. Job satisfaction, you can see this one has a circle, but it's not a star. So this is a high value for job satisfaction. They scored a 4, but it's not starred. So it's not an outlier. It's just a high value. Okay. And then organizational performance has no outliers. That is the visual way to do it. The mathematical kind of statistical way to do it is by creating z-scores. And what you'll do is go to descriptive statistics and descriptives, put in your three variables of interest in this right box, and then check mark this box at the bottom, save standardized values as variables. This will create copies of these three variables, but they will have been standardized around the mean score. Okay, so I'll click OK. And now you can see these are all z-scores, and they have a z at the front of them. Now, according to this citation, z-scores that are larger than 3.29 or lower than -3.29 are outliers, and they should potentially be removed. Okay, so a quick way you can do that is just by sorting these columns in ascending and descending order. So if I sort it in ascending order, we can see the lowest value is -0.97. -0.97 isn't lower than -3.29. So we don't have any low outliers. Then we'll sort it in descending order so we can see the high scores first. 2.79 is lower than 3.29. We don't have any outliers on the high end either. Do the same thing here, job satisfaction, no low outliers, no high outliers. This was that value. This person who scored a 4. You can see this one's pretty close, 3.24. This was a circle in the box plot. So it was this value right here, but it's not starred, remember, so it's not an outlier. And then organizational performance, no outliers in the low direction or the high direction. The next step is looking at Chromeback Alpha. Okay, so Chromeback Alpha is telling you how consistent participants were in responding to your survey. And usually this is used with Likert scale surveys, strongly agree to strongly disagree, something like that. All of these are Likert scales. So to do a Chromeback Alpha check, we go to Analyze, Scale, Reliability Analysis. And just to illustrate, we'll put in leadership effectiveness. You put all the items that comprise the instrument in the right box, give it a name, and you can either click OK or paste. So I'll click paste, so I have the code for it. Highlight the code, click the green arrow, and we can see that the Chromeback Alpha was 0.965. Which is really, really good. Anything above a 0.7 is acceptable. So this is making sure that participants were consistent in responding. They weren't jumping around, saying strongly agree and then strongly disagree on the next item. They maintained some consistency in the responses. That's what this is showing. Okay, so now we can save again. Here's where we created composite scores and looked for outliers. Really the final step. Okay, so that was the final step, at which point I would just call the spreadsheet final once you've made all the adjustments. Final, and at this point you could run descriptive statistics on this. You could run correlations between variables. You could do a regression model. Data is ready to be analyzed at this point. So that's what I talk about here. Now you can kind of dive into your chapter. First, look at the demographic factors, gender, ethnicity, education. That's usually the first part of the chapter. If you collect that data, and then you look at the variables of interest. You can use means and standard deviations to summarize them. If you go to Analyze, Descriptive Statistics, you were in that menu before, actually, but this is what it looks like. So you can see how people scored collectively. Job satisfaction range from 2 to 4 with an average of 2.79. So it's above the neutral response, meaning that participants had positive job satisfaction. And then the next step is testing the assumptions of your data. So you can check for things like, no matter what test you're running, if you're doing correlations or t-tests or ANOVAs, there are specific assumptions to check for those, like normality and homoscedasticity, homogeneity of variance. This is a really good website to check out for that. If you go to statistics layered, and for instance, a multiple regression. On this website, they kind of break down how to run it in SPSS, how to run a regression. Then they go through the assumptions of a regression. Before you actually run that regression, you need to make sure the data are appropriate. So there are a number of assumptions to verify. Okay, and then once you've checked the assumptions, you can address your research questions with the inferential analysis that you proposed. So I'll now go ahead and do a question and answer session. If you have any questions, you can see our contact information here. If you have any questions about the services we provide, or a free consultation. You can check it out. So yeah, do we have any questions? We're going to send a copy of the webinar and a PowerPoint to each and one of you, to every one of you. That will be tomorrow, tomorrow morning. Okay. So do you have any questions about today's topic, how to run things in SPSS? I see that Sierra put some hyperlinks in the chat box, so you can see the webinar archive, the free resources we provide. Any questions? Is everyone here at the data collection step or the data analysis step, or some of you still collecting data, or are you ahead of the curve completely and you're kind of early on in the dissertation? All right, if we don't have any questions, we can go ahead and proceed. You can join us for our future webinars and just to see what's on the horizon here. It looks like May 11th is our next dissertation webinar, and we'll be discussing defense preparation for quantitative methods. That's usually chapter 3 for most topics. And I believe my colleague David will be presenting this one. And then the following week, we'll be doing a qualitative methodology. So if you're doing a mixed method study, if you're joining this webinar, I'm assuming you're doing quantitative, but maybe you're doing mixed methods. One is for the qualitative methodology webinar as well. But yeah, we'll be sending everyone a copy of the recording. Let us know if you have any questions, and have a great day.